Hello, we're going to go through question 3 on the normal distribution homework. If you haven't had a look at the question already, make sure that you do. Now, in this question, for the first part, we need to see if this model here, a normal distribution with a mean of 15 and a variance of 4, will fit this data. Now, for her journey times, 7% of them are less than 14 minutes, and 31% of them are more than 18 minutes. So what we're going to do is work out, if we use the normal distribution, if this model is a good fit, the probability that x is less than 14 should be close to 0.07. So let's check that now. So on my calculator, go menu 7 and normal CD, because I'm trying to find a probability in this case. Now my lower limit, I'm just going to put something like minus 1,000, and my upper limit I'll put as 14, and my standard deviation, remember, is 2. The variance is 4, so the standard deviation is 2. My mean is going to be 15. So I get an answer of 0.3085. And now what I'm going to do is look at the probability that a journey is 18 minutes or more. So this time we'll be looking at probability that x is greater than 18. So yeah, again, menu 7 and normal CD again. This time I've got a lower limit of 18, an upper limit of something like 1,000, just pick a big number here. The standard deviation and the mean are as they were before. When we do that, we get 0.0668. Now you can see the probability that x is less than 14, that probability is very different from 7%, and the probability that x is greater than 18, that probability is very different from 31%. So then we'd say the probabilities are different so Kira's model is not a good fit. Okay, and with that we'll go on to part B. So Kato believes that Kira's value for the variance is correct, but realises the mean is not correct. So for our model, what this means is we don't know the mean, but we know the variance is still 4. Now in these cases where I don't know the mean, or if I don't know the standard deviation, I need to look at this in terms of the standard values to help me work out what the mean is. So when we talk about the standard values for our standard normal curve, this is where the mean is 0 and the standard deviation is 1 every single time. Now what I'm going to do is, I know that the probability that x is less than 14 is 0.07. So what I want to do is transform this into the standard values. So I'm going to look at what is the probability that z is less than some value, let's say k, is 0.07. Okay, so basically looking at that point of how many standard deviations away from the mean do you have to be in that bottom 7%. So to find out that value, what I do on my calculator is I go menu 7, then inverse normal. I'll put an area, I've already got it there, of 0.07. My standard deviation, because I'm talking about the standard values, my standard deviation is going to be 1. And yet again, because I'm talking about the standard normal, my mean is 0. So when I do that, I get minus 1.47579. So I'm just going to call that minus 1.476. Technically, this is what k is, but we're going to use this in the formula for z in a minute, so I'm going to call it z now. So what this means is, to your fastest 7% of your journeys, okay, that's going to be journeys that are 1.476 standard deviations below the mean, or even further away from the mean than that. So what I'll now do is I use the formula z equals x minus mu over sigma, where x is the actual value of 14 that we're given the question, mu is the mean which we're trying to find, the standard deviation is 2, and z is minus 1.476. When I rearrange this, I get mu as 16.95, and because I'm asked for two significant figures, I round that to 17. If you wanted to, you could also work out the probability that x is, look at the fact that the probability that x is greater than 18 is 0.31 as well. If you want to do those upper values instead, you could also do that, and you should still get the correct value for your mean. So it's probably part C is the one that's been causing the most difficulty. So let's just break this question down. So Kira buys a new car. After driving to work in it each day for several weeks, she randomly selects the journey times for n of these days. So basically we've got a sample of n number of days. And usually in the question we get told what n is, but here we don't. Her mean journey time for these n days is 16 minutes. Okay, so this means the sample mean is 16. That doesn't mean the actual mean is 16 though. Using the refined model, she conducts a hypothesis test to see if the mean journey time has changed. And remember, that word changed is really important in a hypothesis test. We're not just looking at it being more than it was before or less than it was before. We're looking at the change in either direction, meaning that this will be a two-tailed test. And she finds that the result is significant at the 5% level. But what we're going to look at here, so we've got a mean of 17. If this is significant at the 5% level, and if we're looking at a two-tailed test, then we're looking at the change in either direction. So we split that 5% up both ways. So I know I've got an area of 0.025 in both tails. So if the result is significant, it means it falls within this critical region that I've shaded here. We're going to determine the smallest possible value of n. Okay, so what this means is this 16, if we're looking at the smallest possible value of n, this 16 has just about got into this critical region. Okay, so it's not really far into it, it's just got into that critical region. So what we need to do to start off with is look at the standard deviation. Okay, we need to find out how many standard deviations away from the mean, the actual mean that is, that you have to be to fall within that critical region. So yet again, we need to use the standard values. So I need to find the chance that you fall in that critical region with if you've got 0.025 in both tails. So I can use my calculator to check that. You can also in the formula book look at the critical values in it. There is a table in the formula book, but you can also just do it this way in your calculator. So go menu 7, inverse normal, and we put an area 0.025. We're going to keep our standard deviation as 1 and our mu as 0 because we're talking about the standard values. And when we do that, we get z as minus 1.96. So what we now do is normally just thinking, well, okay, I know I'm looking for 16. Why can't I just put this in the calculator? The problem is you might think that you know the standard deviation here, but remember when we're talking about a sample, we need to divide it by the square root of n. So what our distribution becomes, I'll put the line above x to show that we're talking about a sample here. The mean is 17, but the standard deviation is 2 over the square root of n. So what I now do is I'm trying to find out what n is. So yet again, I go back to the formula z equals x minus mu over sigma over the square root of n. And what I'm going to do is I'm going to put in Z as minus 1.96. X is going to be 16, because you'll look at the mean journey time is 16 minutes. Mu is the mean, which is 17. Sigma is 2, the standard deviation, and square root of n is what I'm trying to find. When you rearrange all of this, what you should get is n is 15.37. Now, however, we can't obviously have 15.37 in our sample. And it might be tempting to round this down to 15. But what happens with sample standard deviations is the more values you take, the closer you expect to be to your mean. So we can't round down here. We're going to have to round this up to 16 in this case. And that would be our answer. If you weren't convinced as to whether it would be 15 or whether it be 16, what you could always do is on your calculator, now you've got this value, so you could go normal CD, and in this case, we'd be looking at the probability that X is less than 16, which is from our sample. So we'd put in minus 1000 and an upper limit of 16. The standard deviation, now we can try it out with 2 divided by, let's say we have n as 15, so I'll show you why this doesn't work. And our mean is 17. Now when we do that, we get a value that's greater than 0.025, which is half our significance level. So that wouldn't be valid. If I then go back and change my standard deviation now to 2 divided by the square root of 16, then you can see that just about comes under the significance level. So that's the smallest value n could be. And obviously you can see it will work for 17, it will work for 18, it will work for 19. Those probabilities get smaller and smaller, but 16 is the smallest value where 16 would still be significant.